Hello Python programmers, this is AK. In this video, I'm going to teach you about how to work on AutoML in Python. If you are in machine learning or data science field, AutoML is a familiar word to you. And if you are in the non-machine learning field, then this video is little complicated to understand. By the way, I will try my best to explain the AutoML concept more precisely so both of them can understand what exactly the AutoML is. Okay. So what is AutoML? AutoML is nothing but it is automated version of machine learning. If you are currently learning machine learning, let me put you on one problem. Consider that scenario as you are currently solving one machine learning problem through the regression modeling. So you don't know which regression modeling give you the best accuracy. So if you are not able to guess the best fit model for your problem, then your next approach will be trying to do some different regression modeling on your dataset. So at that time, you take lot of time and lot of machine power to train different regression models on your dataset. So the exact use of AutoML is here only. The use case of AutoML is if you want to find out the best fit regression model on your dataset, you need to feed your clean data into the AutoML libraries. With the help of some AutoML libraries, we can easily find out which model will give you the good accuracy. So if you know the particular pipeline, then you can easily solve the problem and save a lot of time from it. So this is the concept of AutoML. There are a lot of stuffs to discuss about the AutoML libraries in this video. I'm sure that in this video you will get more information about the AutoML. So before starting this video, do like, share, comment and subscribe. These things will help me to motivate and it will bring you more new contents in Python and data science. Let's get started. So after the introduction part, now you have some basic knowledge about the AutoML technique. So let's dive into this problem more deeply. Generally, machine learning is one of the very important process in today's business world. So in every frame where they are using machine learning will follow these below steps to achieve their results. So step number 1 is data collection. So every frame has their own data sources, so they will collect the data from there. So this is the first step, and the second step is prepare the data. We can't ensure that every data is a clean data. Sometimes the data has also some impurities. They have to conduct some pre-processing and data cleaning techniques to clean the raw data. So after they preparing the data, they will head to the step number 3. The step number 3 is choose the best model. So now you have some clean data and you have to feed the data into the model. For that, you have to choose the best model for your data. Suppose if you want to predict something from your data, then you have to choose the regression. Suppose if you want to classify anything, you have to do the classification modeling. So this is the concept of choosing the model. And the fourth step is training your model. Now you have the cleaned data set. You have to feed your data to model for training. So the fifth step is evaluation. So after your model got trained with some machine learning model, you have to check whether your model is performing good or not. For that, you have to conduct some evaluation metrics. There are a lot of evaluation metrics are there. But this is not a video to explain every evaluation metrics. So this video is for the AutoML only. Definitely I will explain the evaluation metrics about one video. Okay. And the sixth step is parameter tuning. The metrics that you took show some bad results. You have to tune your parameter. So in the parameter tuning step, you have to adjust your parameter to get some good accuracy. When you get satisfaction about your model, then you have to start the prediction. That is the 7th step. So these 7 steps are very important for every machine learning workflow. Suppose if you are implementing the AutoML in your general machine learning workflow, you can automate some above steps with AutoML. So what are the steps that we can automate if we implement the AutoML? So the step numbers are 3, 4 and 6. These steps we can automate through the AutoML. So I will show you with some good example of how we can automate the machine learning model with some popular libraries in Python. I know few libraries in Python that are AutoScaleRn, Tpot, AutoGlon. So these are the current popular libraries for implementing the AutoML concept. But in this video, I'm going to cover only the Tpot. Because if I explain the other two libraries, it takes a lot of time. I will definitely explain other two in some time. But this is not a right time to explain all the things. Okay. If you want to know that, just press the subscribe button. So when I upload those videos, you will get some instant notifications. Okay. Now we need to install the Tpot libraries in our system. So you all know the exact Python command to install the libraries. Let me skip that part. Okay. First of all, I don't want to waste your time on writing the code. I will show you the full code first and then I will explain the parameters and other imports in this code. By the way, I already wrote the code for both classification and regression problems. So it is easy for you to understand the AutoML concepts with these two variety of problems in machine learning. Okay. Now I'm starting the code with T-Pod regression. So look at my code. First you have to import some important libraries for performing the task. So I imported the T-Pod regressor, and for the data sets I imported Boston house price data from sklearn module. And the third step, you already know what it will do. It is used for splitting the data set into train and test part. Now for recognizing the Boston house price data set, you need to create an instance called load Boston. So you have to initiate this step if you are using the Boston dataset. It will vary on different datasets. Here we are using the Boston dataset. That's why we are using the load Boston instance. This is simple logic. Before going into the next step, you have to understand one thing. Like in this video, our aim is to find the best pipeline for this dataset. We are not gonna do any prediction on this dataset. And if you want the prediction code, T-Pod library itself has some functions. It will help you to generate the code automatically for the best pipeline. So you don't need to write any code separately for this prediction. So I will show you how to do it in the end of this video. So what your duty is, just stick to this video, don't skip this video. If you skip any single part, you don't understand anything from this video. Now in this step, I split the dataset into two parts. One is for training and another one is for testing. Now this step is very important. Here I declared one instance called T-Pod regressor. In this method, I mentioned a few parameters like generations, population size and verbosity. So let's see what these parameters are. So the generations are like iterations of this program. Suppose if you want to run this program 5 iterations, you have to give the generations value as 5. By giving this value, it runs the program 5 times. If you add more iterations to it, you will get good accuracy as a result. So this is the concept of this parameter. And next one is the population size. To be honest, I don't get any proper information about this parameter in their documentation. I assume like this is for adding the algorithms. Okay, I'm not sure about that, but this is my assumption. So even though I try to increase the size of this parameter, when I increase the size of this parameter, I got some good accuracy compared to the previous one. So this is what that I found from this parameter. Suppose when you know about this parameter, just comment it down so everybody can know about this parameter more clearly. And the final one is the verbosity. So this parameter is very simple one. The use case of this parameter is when you run this block of code, you will see some informations and loading bars in a terminal. So for that, we are using the verbosity. Suppose if you are using the verbosity as 2, you can see the loading bars and information about the model training. And then if you change any numbers in this parameter, it won't affect any model performances. If you change the parameters, means you can see some different information instead of this loading bars and other information stuffs. Okay, so that's all about the main code, and the balance codes are just common codes for every machine learning modeling. If you have some basic understanding, or if you already watched my previous machine learning videos, you already know about this code. So let me skip this explanation and let's run this code. So you can see here this model is now running. Usually it takes some time to show the results. So let's see what it brings to us. Now the results came out from the AutoML. It's suggesting like XGB regressor is a good model for this dataset. And also look at this generations here. If the generation count increases, you will get less error. So why we are calculating the error means, here we are using the regression modeling. For every regression model, we have to measure the error as a prioritized metrics. And we don't need to use any accuracy for judging the performance of this model. Okay, so this is for the regression only, and for classification we have to calculate the accuracy. Next we are moving into the classification part. If you are using the AutoML, you don't need to worry about the syntaxes. So the both syntaxes and code are almost same. So look at my classification code here. I passed a different dataset here. So the dataset name is digits datasets. Nature of this dataset is it will classify the digits by using the image array numbers. Now I feed this dataset into this AutoML model called T-Pod classifier, and look at the results. It brought me some good results, and this AutoML model is suggesting to me if you implement this dataset with the decision tree classifier, it will bring you around 97% accuracy. So this is what the concept of AutoML libraries are. So these AutoML libraries are not only suggesting the best pipeline, it also gives you the code of recommended model that you got. So look at my classification code. I added one last step called tpod.export. So this step will export the Python code file at the end of the compilation. So this is the concept of AutoML in Python. I think this video gave you the clarity about the AutoML in Python. And if you have any doubts about it, just comment it down. I will try to answer your questions. So that's all about this video. Thanks for watching and thank you. See you on next week.